Okay, we're here with Rita to talk about functions and understanding what a function even is. You ready to go?
Yeah.
Okay, so the idea of a function is that you have one input. Usually we talk about that as x. It goes into the function and it spits out exactly one output, and we usually call that y. Okay?
Okay.
And if you put in the same value, you have to always get out the exact same value on the right-hand side. In other words, you can't put in 1x one time and get one y value and then put in that same x value and get a different y value. That's what it means by exactly one output. It's always the same. Okay? That's just how we define a function. So let's look at a few things, and we're going to look at some things that are functions and some things that aren't functions. Okay?
Okay.
So here's a line. Okay, we can see that when x equals 0, y is going to equal this point up here. When x equals 1, y is going to equal this point here. It's not going to equal any other point, right? When x equals 5, y is going to equal this point down here. It's always with this line, you're going to have an x value, and you're always going to get whatever the y value is. Does that make sense?
Yeah.
Yeah, so this is a function. If there was some sort of graph like a circle, then sometimes you could put in x and you would get one value and another value. That's not a function. Okay, so you only want to, it can only give you one y value for each x value. Let's look at a table here. So here we have some x values and we have some y values, and you can see that when x equals 1, y equals 3, when x equals 2, y equals 6, when x equals 5, y equals 15, when x equals 1, just like up here, y equals 3. So we put in the same value here, and we got the same y value out. So this qualifies as a function. If this were some other number than 3, then it wouldn't qualify as a function because we would have put in the same x value, but some different number would have come out. Okay, so this is a function. Make sense?
Yep.
Okay, and we can also write ordered pairs here. Sometimes with a set notation, that's the squiggly bracket, you can put a set of ordered pairs that we could say this is a relation between x and y. And we can ask ourselves, is it a function? Well, we don't have any kind of times where you put a value in for x and you get a different value in for y. In fact, all of these x values are different, so this is also a function. Does that make sense to you?
Yeah.
Okay, now let's look at some things that are not functions, okay?
Okay.
All right. Here we've graphed a linear inequality. So this would be an equation, something like y equals negative 3x plus 6, it looks like, somewhere around there. And we've shaded it. And you can see that all of these are solutions to that linear inequality. Do you remember linear inequalities?
Oh, yeah.
Okay. So now let's just think about this x value right here. When we put in this x value, we get all these values and all these values. So there's more than one value for each x value. So that's not a function. In fact, there's something called the vertical line test. If you can draw a line that's vertical and hit more than one point that satisfies the equation or the inequality, then it's not a function. Over here, if you do a vertical line test, you only hit 1 point, so it's a function. Over here, you hit a lot of solutions, so this is not a function, okay?
Okay.
All right, let's look at a table like we did before. So here, this is very similar, except when we put in 1 here, we get 3. When we go down here, we put in 1, we get a different value. So this violates this idea up here. If you put in 1, you've got to get out 3 every single time. Here we put in 1 one time, we got 3. We put in 1 another time, we got 5. This isn't a function. And we can see the same thing with some ordered pairs here. So 1, 3, and then over here we have 1, 15. That doesn't work either. So these are relations that are not functions. They could be very interesting things to look at, but they don't qualify as a function. Okay, make sense?
Okay, yeah.
Great job.